Nice. So this is on my final exam review packet, and we're talking about inverse trig level 4, right? It's just about as tough as it can get. I don't think I can give you one worse than this, okay? So I have the integral of 1 over the square root of 8 plus 2x minus x squared dx. And I had said to you, of course there's an inside, right? Of course there's an inside, but the derivative of that is what, negative 2x plus 2? And I can't get an x, okay? I can't multiply by x over x. Well, I can, but the x downstairs has to stay inside the integral. I can't move the x out of the integral. So I went all the way to the last piece that could possibly work, so it's got to be an inverse trig, which is only going to be arctan or arcsine. Because there's a square root downstairs, I know I'm looking for the integral of 1 over square root of 1 minus u squared du to be arcsine of u. Right? That's what I'm looking for. So I'm going to manipulate this using algebra, not calculus. Right? This is why we tortured you with all that algebra, so you could be ready for calculus. Everything we had you do was so that when you got here, you could do all of these derivative problems and integration problems. So I'm going to try and complete the square. I don't know if it's going to work, right? So I've got negative x squared plus 2x plus 8, right? And I know I want to group my first two x terms together and leave the coefficient out. Sorry, leave the constant out, right? Well, how do I know that? Because I told you, or because your pre-calc teacher had you do this and they taught you how to complete the square. You probably did it in Algebra 2. You should have in high school. I was a senior in Algebra 2. Passed Algebra 1, started smoking pot, failed geometry, failed Algebra 2, finally. So, but I don't want a negative x squared. I want an x squared. I want a positive 1 as my leading coefficient. So I'm going to take out that negative, and I get x squared minus 2x, close parens, all plus 8. Right? Everybody with me there? Factor out the leading coefficient if it's not a 1. Now, inside I see k. So k is negative 2. The coefficient of x, once I get the leading coefficient of x squared to be positive 1. Say again? Good. Yeah, now k over 2, right, is negative 1. And k over 2 quantity squared is negative 1 squared, which is 1. This is the process every time when I complete the square. Unless you have a different process, and that's fine with me. I don't care. Okay? So I'm going to add 1 inside, but what do I do outside?
Negative 1, minus 1.
So minus 1 outside?
Yeah.
Almost. Plus 1 outside. Plus 1 outside, because this negative 1 that I have, this 1 that I have has actually got a coefficient of negative 1. And I have to get those things to cancel. So now I have 9 minus x plus half of k quantity squared. Oh my God, how much have you learned this semester? So much. And you don't realize it yet, but you're getting close to understanding. You're building a toolkit to understand how the universe was formed. It's pretty freaky. So what do I have now? I've got the integral, right, of 1 over the square root of 8 plus 2x minus x squared dx as the integral of 1 over the square root of 9 minus x quantity x minus 1 squared dx. So I'm getting really close to getting it to look like arcsine, right? Really, really close to getting it to look like arcsine. So, but what don't you like there? Look at my what I want. What don't you like in what I have? The 9, right? So I'd like to factor out that 9 all the way out of the square root, right? So let me do it first with inside the square root. So I've got 9 times 1 minus x minus 1 all squared over 9 dx, right? So that first 9 there can come out now, but what does it come out as in the square root? A third, right? Right? When I take a 9 out of a square root, it becomes a 3, right? So it's really, and because it's downstairs, it's a 1/3 now. Right? Nice. Now what don't I like? Look at what I'm trying to get to again here in this red box here, red black box. I want the square root of 1 minus u squared, right? So it looks like I have a u sub inside now. So u is x minus 1 all over 3, and du is 1/3 dx. Oh, right. I got that. I got a 1/3 dx. Right? I can put that 1/3 back in. So I got the integral of 1 over square root of 1 minus u squared du, right? The 1/3 dx became my du. Yes. Yeah, and again, I'm in no rush, so you tell me what you need me to do. The only thing I'm in a rush for is Taco Tuesday, but I gotta wait. I just hope they're not shrimp tacos today. I hate shrimp tacos. That's what happens when you get old. You only care about food and sleep. Does everybody have this final exam review packet that I'm working on right now? Yeah? No? Any? Is that okay? Nice. So I'm in the big packet on page 4. Marinata, no? You're welcome. I'm on the big packet, page 4. Rosie, sorry. Big packet, page 4. So it looks like I'm done, right? Because now I see I have my arcsine of u all plus c, but I know u is x minus 1 all over 3, right? Arcsine of x minus 1 all over 3 plus c. And that's it. I don't know if that one, I actually think the one we did first that Diego sent me to do is probably more difficult because I have to do a couple more steps, right? I had to create du by multiplying by 1 and adding 0 then I had to divide and conquer, then I had to do a u sub, and then another u sub, right?
The 3du got cancelled out by 1/3.
Say again?
The 3du got cancelled out by 1/3.
Yes, exactly. Well, the 1/3 dx, 1/3 dx is my du, right? So there's my 1/3 dx right there, that du, right there. So looking at all of this stuff, page 16 I did not teach you this semester. So page 16 you can cross out. Nice. So what am I thinking about for the quiz Thursday? I'm thinking about probably, well, why not everything? The only thing this packet is missing is a substitute downstairs. So we better do a couple of those, right? I don't know. I don't even see any good ones on here either. I'm missing something. Sorry. Definitely an area problem. You want to do an area problem. Definitely U subs, all of the U subs. Right? Do we want to do an area problem? I could ask you to do two different area problems on the quiz and or the second midterm, only one on the final. Okay?
Sorry, could you please repeat that?
What's that? Yeah. It's possible I could ask you to do two different area problems on the quiz, on the midterm, but on the final will only be one area problem. So let's do an area estimate with 4 rectangles. So how about the integral of e to the x squared dx from 0 to 4 with 4 rectangles? So it turns out that this one we can't do. We can't do this integral, but I can estimate the area. What looks like the problem with this? What would u be in this case? What? X squared, and then du would be 2x dx. And the problem is, of course, I can't get that x to happen, right? I can't multiply by a variable inside an integral and cancel it outside the integral. I can't move x through my integral. Now, I can do this one on the calculator, right? So this fails. This is an integration method that we can't do until chapter 8 in Calc 2. On the calculator,
Wait, can you go over why these are the ones?
yeah, so you agree with my DU? Yeah. So what would I have to try and do? Put in a 2, that's no problem. But how do I put in an x? Because this integral, remember this is an integral with respect to x, so meaning x can't move in and out of the integration, it's dependent upon it. So I can't do that. And there's no other, in my list of 12 things, it's definitely not an arc tangent or arc sine. There's no downstairs, right? There isn't inside. I tried that, it didn't work. Nothing else looks like it would work. But since I'm asking you just to do this, what's this graph look like, by the way, right? Desmos. I mean, I think you know what it looks like, but right, kind of looks like a parabola. And I guess it's a little unfair that I said from 0 to 4, because it's pretty damn high at 4. It's still countable. It's still doable, right? But you get the idea, right? 1, 2, 3, 4. Right? We're getting those areas, yes?
Are you going to tell us when to do the areas?
Yeah, I will always, yeah. And it will always be 4 for me. Because it's just too much work to do the rest. So let's take a look at our calculator, what it gets, right? So y equal e raised to the x squared. Graph, make sure I can see 0 to 4. Obviously I can, right? I don't care about the height, I just want to make sure I see the bounds of the integral on the screen. I do second calculate 7 for integral. Lower limit is 0, hit enter, and then upper limit is 4, hit enter. So it looks like 1 billion, yeah. 114900.6. Oh, so 114,900.6, right? Let me just double check that. 1149400. Sorry, I thought it missed one. 400.6. So, but now we want to use our rectangles, right? So I'm doing the integral from 0 to 4 of e to the x squared dx. And that's going to be approximately equal to the sum from I equal 1 to 4 of e to the x sub I squared delta x, right? F of x sub I times delta x, yes? And you can clearly see, so what is delta x? Well, it's 4 minus 0 over 4, so it's 1. And you can see the base of each rectangle is 1, right? And x sub I is 0 plus delta x times I, so it's just I. 1, 2, 3, 4, right? Every time I'm going to my next index, right? First rectangle, height of 1. right? Second rectangle, height of 2. Third rectangle, height of 3. So we can clearly see that we're doing the sum from I equal 1 to 4 of e to the I squared, right? Times 1, delta x is 1, right? So what do I get? I get e to the 1 squared plus e to the 2 squared plus e to the 3 squared plus e to the 4 squared. Everybody with me? I want to try and make this look as pretty as I can. It doesn't get much prettier than this, but clearly I can do e plus e to the 4 plus e to the 9 plus e to the 16. And that's my answer, and then I'm going to my calculator from there. E to the 1 plus e to the 4 plus e to the 9 plus e to the 16. And I should get more than 1.1 million, right? Because I did an overestimate. So e plus e to the 4 plus e to the 9 plus e to the 16. It's a way overestimate, right? And you can tell from the fourth rectangle, right? That fourth rectangle is so tall, right? Even the third one I can't even see on the screen. So those two are giving me so much more. What do I get, 8 million here? Yeah, 8 million. 8.9 million, certainly bigger than 1.1 million. 8894270. 0.921. So guess what kind of function I'm going to ask you for on Thursday. What kind of function do we love so much that Robert keeps torturing us with it? What? And like this one? Yeah. Trig. Let's take a little break. Let's come back at 10:10.